For almost a century, scientists have looked into the universe and realized something isn't adding up. Galaxies spin at impossible speeds. Stars at the outer edges move so fast, they should have been flung into the void. And yet everything stays in place. It's as if an invisible hand holds the cosmos together, a force that doesn't shine, doesn't emit radiation, doesn't interact with light in any known way. It is invisible, but it's everywhere. Physicists named it dark matter. And now, new research suggests we might finally be standing at the edge of one of the greatest discoveries in human history, the first possible detection of dark matter itself. But before we dive into this new finding, we need to understand the mystery we're dealing with and how it has haunted science for decades. Look around you. Everything you can see, the screen, the air, the earth, the sun, the stars, is made of what we call baryonic matter, or ordinary matter. It's built from atoms, protons, neutrons, and electrons. But here's the shocking truth. All of that accounts for only 5% of the universe. The other 95%? It's completely invisible. Roughly 27% is dark matter, and the remaining 68% is dark energy, a mysterious force pushing the universe to expand faster and faster. In other words, everything we've ever seen through telescopes, every galaxy, every nebula, every explosion, it's just the tip of the iceberg. The vast majority of the universe is something we can't see, can't touch, and don't fully understand. It's like we're watching a cosmic play, but only 5% of the actors are visible. The rest are hidden behind an invisible curtain, silently controlling the show. The idea of dark matter first appeared in the 1930s with the Swiss astronomer Fritz Zwicky. While studying the Coma cluster, a huge collection of galaxies, Zwicky noticed that the galaxies were moving far too fast. There wasn't enough visible mass to keep them gravitationally bound together. Something else, something invisible, was adding extra gravity, preventing the cluster from flying apart. He called it dunkle Materie, or dark matter. At the time, many dismissed his claim as wild speculation, but decades later, new evidence began to pile up. In the 1970s, the American astronomer Vera Rubin studied the rotation of galaxies. She discovered that stars far from the galactic center were orbiting just as fast as those near the core, something that shouldn't happen if only visible matter was there. That was the smoking gun. There had to be an unseen component, a halo of invisible mass surrounding each galaxy. Without it, galaxies would simply tear themselves apart. From that point on, scientists have been trying to understand what dark matter really is. They know it's there because of its gravitational effects. They know it doesn't interact with light. That's why it's invisible. But beyond that, it's a mystery. Over the years, many theories emerged. Some say dark matter could be made of exotic particles known as WIMPs, weakly interacting massive particles. Others suggest axions, hypothetical particles that could fill the universe like a ghostly sea. Some even propose that dark matter might be composed of countless tiny black holes formed just after the Big Bang. But despite decades of research, no one has ever directly detected any of these candidates. Every experiment so far has come up empty, until now. Maybe. Let's travel to the center of the Milky Way, about 26,000 light-years away. It's a chaotic region filled with stars, dust, supernova remnants, and at its core, a supermassive black hole known as Sagittarius A. It's also the perfect place to look for dark matter. Why? Because gravitational simulations show that dark matter should be densest at galactic centers. If dark matter particles exist, they might collide and annihilate each other there, releasing powerful gamma rays, the most energetic form of light. And that's exactly what scientists have been observing. Using NASA's Fermi Gamma Ray Space Telescope, which has been orbiting Earth since 2008, researchers detected a strange glow of gamma rays coming from the center of our galaxy. This wasn't a random signal. It was persistent, consistent, and stronger than expected. At first, scientists thought it might be caused by pulsars, rapidly spinning neutron stars that emit beams of radiation. But the numbers didn't match. There weren't enough pulsars to explain the intensity or the shape of the signal, so the question became impossible to ignore. Could this be the first real trace of dark matter? To find out, researchers turned to computational simulations, virtual models of the Milky Way built using physics, gravity, and particle behavior. They ran thousands of scenarios, some with pulsars, some with supernova remnants, and others with dark matter particles. Each time, they compared the simulated gamma ray patterns with the real data from Fermi. And something remarkable happened. The models that included dark matter annihilation, particles colliding and releasing energy fit the observations significantly better than any other. Explanation: it's not definitive proof, but it's the closest we've ever been. The signal behaves just like scientists predicted dark matter would if it were made of particles that occasionally collide and disappear in flashes of energy. That's why this discovery sent shockwaves through the astrophysics community. For the first time, we may be seeing the invisible, not directly, but through its deadly dance of destruction. Imagine two dark matter particles drifting through space. They don't interact with light, but they do have mass, and they can attract each other gravitationally. When they meet, their energy is converted into radiation, particularly gamma rays, which are then detected by telescopes like Fermi. If enough of these collisions happen in a region as dense as the galactic center, they would create a constant background glow, exactly like the one we're seeing. In other words, the universe might be whispering the secret of dark matter right in front of us, and we're finally starting to hear it. But as exciting as this is, science demands evidence beyond coincidence. That's where the next step comes in. A new generation of telescopes is about to enter the scene, the Cherenkov Telescope Array, or CTA. It's being built in Chile and will be the most powerful observatory ever designed to detect high-energy gamma rays. With unprecedented precision, the CTA will be able to tell whether these mysterious rays truly come from dark matter interactions, or if they're just the combined noise of thousands of unseen pulsars. The project is set to begin full operations in 2026, and when that happens, humanity may finally be able to confirm or deny one of the biggest hypotheses in the history of physics. If dark matter is confirmed, it will rewrite the very foundations of cosmology. It would explain how galaxies formed, how the universe grew, and maybe even how it will end. Right now, all our models, from the Big Bang to cosmic expansion, depend on dark matter and dark energy existing. Without them, none of our equations make sense. In short, we've built our understanding of the universe on an invisible foundation we can't yet prove exists. Confirming dark matter would finally turn that foundation from faith into fact. It would be like turning on the lights in a dark room we've been navigating by touch for centuries, and who knows what else we might discover once we can finally see the invisible 95% of reality. Some physicists believe dark matter could be connected to new dimensions or unknown forces of nature. It could bridge the gap between Einstein's general relativity and quantum mechanics. 2. Theories that describe the universe in completely different ways. Others wonder if dark matter might hold clues to parallel universes, or even to what existed before the Big Bang. If dark matter is made of undiscovered particles, studying it could lead to a new physics beyond the standard model, a deeper understanding of everything from gravity to time itself. In a sense, dark matter could be the missing link, the key to uniting all the laws of the cosmos under one grand theory. But there's also something profoundly human about this search. We've spent thousands of years looking up at the stars, thinking we understood what we saw. Now we realize that most of reality has been hidden from us all along. Dark matter is a reminder that the universe is far greater, far stranger, and far more mysterious than we ever imagined. It humbles us and inspires us, because if we can uncover the invisible architecture of the cosmos, then maybe, just maybe, there are no limits to what we can discover next. So has dark matter finally been detected? Not yet, but for the first time, the universe might be showing us its shadow. Those faint gamma rays from the center of the Milky Way could be the whispers of a hidden world, a world that holds the key to the formation, evolution, and destiny of everything that exists. In a few years, when the Cherenkov telescope opens its eyes to the heavens, we might finally know the answer. And when we do, humanity will cross a line it has been approaching for nearly a century. We will go from believing in the invisible to understanding it. And when that moment arrives, the story of the universe will never be the same again.